The story of humanity is a grand and sprawling epic, a tale of innovation, survival, and exploration that has taken our species from the savannas of Africa to the surface of the moon. Yet, for all we know about our recent history, the very first chapters of our book remain shrouded in a deep and profound mystery. Where did we truly begin? What did our most ancient ancestors look like, and how did they live? For generations, these questions have echoed through the halls of science, pushing explorers and thinkers to search for answers buried deep within the Earth's crust. The fossil record, our only direct window into this distant past, is frustratingly incomplete, with vast gaps of millions of years where we have found almost nothing. This immense void in our knowledge is particularly pronounced around the time our lineage is thought to have split from that of our closest living relatives, the great apes. This was a pivotal moment in the history of life, the instant a new kind of creature began its journey towards becoming human. Finding any trace of these earliest hominins, the group that includes modern humans and our extinct ancestors, is like searching for a single precious jewel in an endless desert. Each discovery, no matter how small, offers a tantalizing clue, a faint whisper from a forgotten world. It is this hunt for our own origins that drives paleontologists to the most remote corners of our planet, hoping to uncover the fossil that will rewrite everything we thought we knew. Imagine a time, 6 million years ago, when the African landscape was still being shaped by immense geological forces. The Great Rift Valley, a colossal tear in the continent's surface, was a dynamic world of volcanoes, forests, and sprawling grasslands. It was here, in this cradle of life, that the first steps toward humanity were likely taken. But for a very long time, the evidence was missing. We had fossils like the famous Lucy, an Australopithecus afarensis who lived just over 3 million years ago. But the time before her was a great unknown. What happened in the millions of years leading up to Lucy? Who came before? This was the puzzle that haunted scientists at the turn of the new millennium. The search for our ultimate ancestor is more than just a scientific quest. It is a search for ourselves. Understanding where we come from helps us to understand what we are today. The traits we consider uniquely human, our large brains, our complex cultures, our ability to walk on 2 legs, did not appear overnight. They were forged over millions of years of evolutionary trial and error. To find the very first evidence of one of these traits, such as walking upright, would be to find the dawn of our own story. And in the year 2000, in the sun-drenched hills of western Kenya, a discovery was about to be made that would shine a brilliant new light into this ancient darkness. The Tugen hills of Kenya are a starkly beautiful, yet rugged and unforgiving landscape. These rolling hills form part of the Great Rift Valley, a place renowned for its rich deposits of ancient fossils. For years, a dedicated team of French and Kenyan scientists had been combing this area, convinced that its ancient rock layers held secrets to our earliest origins. The team was led by 2 prominent paleontologists, Brigitte Senout from France and Martin Pickford from the United Kingdom. They knew that the sediments here were of a critical age, dating back to that mysterious period 6 million years ago when the human family tree was just beginning to sprout its first tentative branches. Their persistence was fueled by a deep understanding of the land and its history. They worked closely with local people whose knowledge of the terrain was unparalleled. One such individual was Kiptalam Chepboy, an experienced fossil hunter from the region whose sharp eyes had been trained over many years to spot the subtle signs of ancient bone hidden amongst the rocks and soil. It is often the case in paleontology that great discoveries are not made in a single flash of genius, but through patient, methodical work day after day under the blazing African sun. The team spent countless hours scanning the ground, their hopes rising and falling with each passing day. The name given to the project, the Kenya Paleontology Expedition, hints at the grand scale of their ambition. They were not simply looking for any fossil, they were hunting for a hominin, a member of our own ancestral line. The layers of rock in the Tugen Hills, known to geologists as the Lucano Formation, were a perfect target. These layers were sandwiched between beds of volcanic lava, which could be accurately dated, providing a reliable clock for any fossils found within them. The team knew that if they found something here, they would be able to say with confidence just how ancient it was, potentially pushing back the dawn of humanity by millions of years. The work was arduous and often frustrating. The landscape is vast, and the fossils are incredibly rare. For every significant find, there are thousands of hours of fruitless searching. But the team's belief in the potential of the Tugen Hills never wavered. They were driven by the conviction that the answers to humanity's deepest questions lay sleeping beneath their feet, waiting for the right person to come along and awaken them. They were on the verge of a breakthrough that would not only reward their tireless efforts, but also send shockwaves through the world of science and forever change our understanding of the human story. The moment of discovery, when it finally came in October 2000, was not a dramatic, earth-shattering event, but a quiet, electrifying revelation. It was Kiptalam Chepboy who made the initial find. While scanning a familiar hillside, his expert eye caught something unusual. It was not just a rock or a fragment of a common animal bone. It was a fossilized molar tooth, and its shape was tantalizingly human-like. In the world of fossil hunting, teeth are treasures. Their durable enamel allows them to survive for millions of years, and their size and shape can reveal a great deal about an animal's diet and its evolutionary relationships. This tooth was different. It hinted at something extraordinary. The excitement within the team was immediate and palpable. A single tooth might not seem like much, but for paleontologists, it is a powerful clue. Brigitte Senot and Martin Pickford knew at once that they were onto something significant. The find spurred a more intensive search of the area, with every member of the team now filled with renewed energy and focus. They began to carefully excavate the surrounding sediment, their tools moving with a surgeon's precision. What they started to uncover was beyond their wildest hopes. One fossil fragment led to another, each piece a new part of a puzzle that had been scattered for 6 million years. Over the following weeks, the team unearthed a total of 13 precious fossil fragments. These were not all from a single individual, but represented at least 5 different beings who had lived and died in this very spot long ago. Among the finds were pieces of jawbones, more teeth, and most importantly, parts of limb bones. There was a piece of a humerus, the upper arm bone, and several fragments of a femur, the long and powerful thigh bone. Each fossil was carefully cleaned, documented, and prepared for analysis. The camp must have been buzzing with a quiet, intense excitement as the true significance of their discovery began to dawn on them. They had found more than just old bones. They had found the remains of a potential human ancestor, one that was far older than any other contender known at the time. They decided to name their discovery Orrorin Tugenensis. The name itself is steeped in local significance, a tribute to the place and its people. Orrorin means original man in the Tugen language, a fitting title for a creature that stood at the very dawn of our lineage. Tugenensis simply means from the Tugen Hills, forever linking this ancestor to the land where its story was rediscovered after an eternity of silence. The true importance of the fossils became clear when the scientists began to study the femur, the thigh bone. This bone is one of the most informative parts of the skeleton for understanding how an animal moved. In animals that walk on all fours, like chimpanzees, the femur has a particular shape. But in animals that walk upright on 2 legs, a mode of locomotion known as bipedalism, the femur looks very different. It has to be strong enough to support the entire weight of the body with each step, and its structure reflects these immense forces. The head of the femur, the ball-like part that fits into the hip socket, is especially telling. Upon examining the femur, the scientists noticed features that were strikingly similar to those of modern humans. The bone was thick and robust, and the femoral head was large and spherical. Most importantly, the neck of the femur, the part connecting the head to the main shaft, was long and flattened in a way that is characteristic of bipeds. This structure helps to distribute weight and stress efficiently during upright walking, while the arm bone, the humerus, still showed features adapted for climbing trees. The evidence from the thigh bone was a powerful signal. Was not just another ancient ape. It was a creature that spent a significant amount of its time walking on 2 legs. This was a groundbreaking revelation. Bipedalism is considered one of the foundational traits that set the human lineage apart from other apes. It freed the hands for carrying food, tools, and infants, paving the way for all the technological and cultural developments that would follow millions of years later. Finding evidence of upright walking in a creature that lived 6 million years ago was astonishing. It suggested that this crucial evolutionary step occurred much earlier than previously thought. Before, the most famous early biped was Lucy, who lived around 3.2 million years ago. Millennium Man pushed the origins of this key human adaptation back by nearly 3 million years. The discovery immediately sparked intense debate within the scientific community. Some researchers were skeptical, arguing that the fragments were too incomplete to draw such a firm conclusion. But Senut, Pickford and their colleagues stood by their analysis. They argued that the combination of features, a femur built for walking and an arm bone still suited for climbing, painted a picture of a transitional creature, one that was comfortable both on the ground and in the trees. This is exactly what one might expect to find in an ancestor so close to the evolutionary split between humans and chimpanzees, a creature navigating a world that was changing from dense forest to a more open savanna. Discovering remarkable fossils is only half the battle. Determining their age is just as crucial. Without a reliable date, a fossil is just an anatomical curiosity, its place in the grand evolutionary narrative unknown. For establishing its age was a challenge, but one that the unique geology of the Tugen Hills was perfectly suited to solve. The fossils themselves cannot be dated directly over such a long time span. Instead, scientists had to become geological detectives, reading the story written in the layers of rock where the bones were found. The secret to unlocking age lay not in the fossils, but in fire and ash. The Lucano Formation, the geological stratum that held the Millennium Man fossils, is part of a sequence of sediments that were deposited over millions of years. Crucially, this sequence is punctuated by layers of volcanic rock. The Great Rift Valley was, and still is, a hotbed of volcanic activity. Periodically, massive eruptions would blanket the landscape with lava and ash. These volcanic layers create perfect time markers in the geological record. Using a technique called radiometric dating, scientists can measure the decay of radioactive elements, such as potassium and argon, trapped within the volcanic crystals. This process acts as a highly accurate natural clock. The fossils were cleverly sandwiched between two such volcanic layers. One layer of lava lay directly beneath the sediments where the bones were found, and another layer of volcanic tuff lay above them. By dating these two layers, the scientific team could establish a definitive age bracket for Millennium Man. The lower layer was dated to approximately 6.2 million years old, and the upper layer was found to be around 5.65 million years old. This meant that must have lived and died sometime within this window. The team settled on a conservative estimate of approximately 6 million years old, an age that was simply staggering. This ancient date placed directly in the time frame when genetic studies suggested the human and chimpanzee lineages had diverged. It made Millennium Man a prime candidate for being one of our very first ancestors after that momentous split. The discovery challenged the prevailing view that the human line began with creatures like. Suddenly, Lucy was no longer the matriarch of the human family. She had a potential ancestor who was twice her age. The careful geological work and precise dating were essential in cementing place as a pivotal figure in the story of human evolution, forcing a complete re-evaluation of our family tree. The discovery of was more than just another fossil find. It was a fundamental shift in our understanding of where we come from. It suggested that the journey towards humanity began far earlier than we had ever dared to imagine. The revelation that an ancestor was walking upright on two legs 6 million years ago redrew the map of human evolution. It implied that bipedalism, not a large brain, was the first major innovation that set our ancestors on a different path from the other apes. This idea turned many long-held theories on their heads and opened up a whole new chapter in our prehistoric past. Millennium Man reminds us that the story of human evolution is not a simple linear march of progress from an ape-like creature to a modern human. Instead, it was a complex and branching tree, with many different species of hominins coexisting and competing on the ancient African landscape. Some of these branches, may have led towards us, while others eventually withered and went extinct. The fossil record is a testament to this messy, beautiful, and intricate process of trial and error. Discoveries help us to fill in the gaps, but they also reveal just how much more there is left to learn about our extended family. The story is, of course, far from over. Science is a continuous process of discovery and revision. Even today, new finds are constantly challenging our perspectives. For example, recent discoveries of fossilized footprints in northern Kenya show that even as late as 1.5 million years ago, different hominin species and were walking across the same muddy flats. Our own species also shared the planet with other humans like Neanderthals until relatively recently. The past was a much more crowded place than we once thought, filled with a diverse cast of characters in the epic drama of human origins. Ultimately, the legacy of Millennium Man is one of wonder and inspiration. It is a powerful reminder that the ground beneath our feet holds profound secrets about our own identity. The patient work of scientists like Bridget Senut and Martin Pickford, and the keen eye of local experts like Kiptalam Chetboy, brought to light an ancestor who had been lost to time for 6 million years. The original man from the Tugen Hills stands as a testament to the enduring quest to understand our place in the natural world, and it assures us that the greatest discoveries about our own dawn are perhaps still lying in wait, ready to be unveiled.